Peer-to-peer reminds me a lot of that kind of like discussion where today people will say, why does it matter that you authenticate where the data comes from and that you can authenticate it on rest? And I feel like in 20 years, we're going to be like, why didn't we not always do that? Because it's just, even though it takes a bit more compute, it opens up a bunch of interesting security avenues and also just distribution avenues.
This is DevOps Paradox, episode number 322, How to Build Apps That Never Go Down, Even When Servers Die. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. In this world, we've been used to putting applications on servers and running them. I mean, heck, Victor, how would you even run Kubernetes without servers?
It depends what you mean by servers. How would I run Kubernetes on thin air? I cannot. I need to run it on something.
Need to run it on something. Well, today we have Matthias Boos-Mattsson on. Matthias Boos. Matthias, how you doing?
I'm good. How are you?
Good. Does this conversation make any sense? Can you run applications without servers?
Yeah, of course. We obviously need some sort of computing device. I'll concede that one immediately.
That's a server.
Well, it depends on my personal litmus test is like, what would my parents call it? And they would definitely say something in a data center is different than the device they're using. So I think it's like less about running things on servers and more about running things on end user devices. Let's put it that way.
Okay. So if you don't know who Matthias is, we typically don't do bios, but this one I'm going to go ahead and throw in there. You've written over 1,000 NPM modules. I'm so sorry that you've written 1,000 NPM modules.
Yeah.
And you've been doing peer-to-peer stuff. You're currently a co-founder of Bear. You also created the Pair runtime, which is, it's all about peer-to-peer. Now, to me, peer-to-peer was cool in 2000.
It was cool because that's how we were watching all the movies back in the day and listening to all the music, right?
This was Napster, right? That's where I'm going to is Napster. But since then, it's like, it's a so what technology to me. Am I wrong in that thinking?
I think the public perception and what you said from like an end user point of view is definitely peer-to-peer peaked around that time. I find it very interesting why it peaked around that time. It's basically because there was a time when we used technology to work around a problem. For end users, the problem was lack of content available online. And there was a big movement towards that, obviously, with a bunch of legal implications for a lot of people involved. That's a whole different discussion. But it showed in that period of time the power of making software, again, that just runs at end user devices, can't be controlled by any like entity. And it also, for me, showed the power of, to some degree, open source and like open technology in terms of just making simple stacks that users can run and kind of like turn into this like network of many and solve a problem for the user and do that with like so much force that it couldn't be stopped. I'll be the first one to totally concede your point. I think, that's also in like public perception that kind of peaked there, maybe not 2000s, but like around that time. And it's also around that time I got personally started in intense peer-to-peer work. I'm from a small country. I'm from Denmark, and we definitely had a lack of content availability in a small market there. And that was like the part of why these kind of things were very big in the Nordics, I think. I got involved on a technical level back then, writing, again, like I said, I wrote a ton of modules, but also writing just tons of software to work with BitTorrent back then, which was my introduction to that. I'm a little bit too young. I'm not very young, but I'm a little bit too young for Napster. I'm just around the time when Napster died off and BitTorrent took over. I find BitTorrent a very interesting technology. My whole career has been around how can we take those components that proved so powerful for file distribution in the BitTorrent era and so unstoppable. And everybody tried to stop it. I say this all the time. Everybody and their mother who was in charge of anything tried to stop it, including governments, including, serious business, and it couldn't. The only thing that actually tapered off the man was other apps tried to appear to do more centralized approach to kind of like lure people back, like Netflix and stuff. But how can we take that technology and those ideas and apply on a much broader scale than just file sharing, but like to disrupt any kind of application out there with like normal data flows, like chat, like social networks from a technical point of view, and obviously allow users to build applications like that. That's basically my mission and my company's mission today.
So I'm trying to figure out, you said data flows. I'm going to think a little bit higher. It's like a typical flow for me is user hits an endpoint with a browser, server processes it, does whatever, hits the database, comes back through the server, gives it to me. I mean, what is flow in a peer-to-peer world? Because again, to me, and I almost started crying when you said you're too young to remember Napster. My daughter was already in her mid-teens by the time Napster was starting to die off. I'm just trying to think. I mean, I get it, right? I understand, and I really didn't use Napster a lot either. But the BitTorrent, bringing up BitTorrent, because I'd actually forgotten the phrasing, it makes a big deal for things that are, let's call it legal for the moment. It's a big deal for the illegal things too, but legal things, it can save a lot of cost, perceived cost though, because it still costs somebody something. So anyway, let's talk about the flow first, because it's like, I don't really understand, again, typical web, back to the back to me. That makes sense. How does it work in peer-to-peer?
Yeah, you bring up a lot of good points. I gotta first say, I'm also not very young. I'm just a little bit older than Napster, so younger than Napster. So just before somebody thinks I'm a young hip guy. Yeah, it's a very good point. It's kind of, I think it's like there used to be a thinking, and there's also it was very dominant when I took it like a slightly formal education in computer science and things like that, about data flows being point-to-point driven, meaning that data flows is something that happens when you call an IP. Today we used host names, but like some sort of endpoint that points to something very specific. And it's that specific entity that gives you the data. And that's how you work with the data. Peer-to-peer is all about saying it doesn't matter who has the data as long as we can verify it. So it's a much more, to some degree, even though it's a very old idea, it's like a very modern take about doesn't matter where data is served from, as long as we can authenticate it from our point of view that it came from the right source originally. Anybody can help us host it and host piecemeals of it and stuff like that. And that's like the fundamental difference. And it sounds maybe like a small difference, but that's the thing that makes everything different. And that's why in the P2P network, like in BitTorrent, I can go to my worst enemy and I can have them serve me content over BitTorrent, and they can try to trick me, but I can always verify on my end if that content is correct through a very, once you understand it, simple protocol of like cryptography and stuff. And that's the big difference. And I think we've been through a lot of cycles like this, especially in computer science. I remind myself often when I started out doing serious computer science, and that was around that time. That was before we had widespread encryption on the web. And because the web, as you say, is much more based around this point-to-point communication. Obviously, there's data centers and load balancers will try to route, but at the end of the day, it's point-to-point. When I started out in that, encryption on the connections was kind of thought of as a let's see kind of thing, because it's going to create a bunch of cost and infrastructure is not ready for it. And do we really need it? And you had to have all these trade-offs about like, maybe this thing needs encryption, maybe this thing doesn't, to kind of like help run these things. And today, based on all we know today, we're like, why would you ever run anything unencrypted on the web just in the current climate? And looking back at those decisions today, even though it's only like 15, 20 years ago, how many watches, I'm thinking like, wow, we didn't know anything. And P2P reminds me a lot of that kind of like discussion where today people will say, why does it matter that you authenticate where the data comes from and that you can authenticate it on rest? And I feel like in 20 years, we're going to be like, why didn't we not always do that? Because it's just, even though it takes a bit more compute, it opens up a bunch of interesting security avenues and also just distribution avenues.
Well, in this context, it doesn't appear that people care about having more compute, because with the AI craziness that's going on, it's like compute is going through the roof.
Well, some compute is going to. Computers has always been going through the roof, right? It's kind of like the devices we have today. That's that comparison, with how much power we needed to go to the moon compared to how much we have in a random smartwatch today, or even just rendering this podcast. I'm sure we're in magnitudes over, right? So compute has this nice way of scaling well, and obviously for AI, there's different challenges and stuff. I think it's more about using the compute we have today to unlock these things, because there's no reason why the compute we have today is not enough to run these peer-to-peer networks, and that's what we're trying to do and are doing with our technology. So I don't think it's necessarily like we need to have more compute out there. It's just that we need to be a bit smarter, and that's kind of like what I meant with like the encryption analogy. Like we have the technology available already. The upsides are insanely strong. The downsides is it's new and scary, and also obviously there's, like with anything else, like there was with the encryption push back then, unknowns here and there, but it's what we need to do.
So am I wrong in saying that the whole premise of peer-to-peer lies in among others on an assumption that people are willing to share their compute for the common benefit in a way, right? Including their own.
I think that's a very interesting phrasing, and I think that's depends on how you look at it. I think at the core point of view, peer-to-peer actually doesn't require that, because peer-to-peer, like I said, is just about sovereignty of data. It's about having systems where you can always prove that the data came from some source originally, like it's verifiable on my end, not just like I trust that I got it by some server saying this is correct. I can always, run an audit on my end. Whether or not a user in that network wants to share that data to other people, that's actually just like a side feature that obviously unlocks tons of possibilities and makes the network better. But you can easily build peer-to-peer systems where that's not a use case, because the peer-to-peer aspect, just almost by the name, just says there's no difference between me as a peer and you as a peer. So like the trust I need to put in you as the provider of data to me is the same as the trust I put in anybody else. So it's just a very, very powerful idea around building these insanely trustworthy and scalable applications. And you can kind of tweak the rest of the metrics, I think.
But if I'm a company and I build for my storage or applications or whatever needs peer-to-peer, how is that different? And I'm saying now build it on my hardware, not your hardware, right? How is that different from non-peer-to-peer?
It obviously, depends on what you're building and stuff, but it basically just means that, kind of like what I meant with encryption also when I said earlier, there's no really thinking about it. Like the systems are inherently built this way to be defense and dev and self-verifiable and self-healing. So if you wanted to build a data distribution network just in your data center and guard that with some endpoint, which I'm sure a lot of people want to do today for various reasons, you would just make that with normal peer-to-peer primitives. There's tons of stuff for data centers you can do to build these kind of things yourself. You said Kubernetes earlier. Kubernetes does something of that sort also, I think, for the distribution aspects. They tend to also fall down to I don't mean this in a bad way, but a weak version of peer-to-peer where they probably don't do as many consistency checks and defensive things, because they're you're running in an untrusted environment. But peer-to-peer for me, kind of going back to the encryption discussion also, is just this fundamentally the superior version of that, because it just gives you that defense and that. Even in a system like that, what if you have sensitive data in there and somebody breaches your firewall, which is how we normally defend these things? Then you have much fewer options about defense and dev in the classic systems, where peer-to-peer system is always trying to guard against everybody, right? So it doesn't treat peers differently. The only thing you can kind of do in a peer-to-peer system to be nice is have, like you said, longer uptime on your nodes, or share more data with your nodes. And that's kind of the model you would run inside a data center. I think, honestly, not even trying to be super biased, I think it's just a superior model in these kind of ways. Obviously, there's tons of tooling and existing tech that needs to adapt, but the ideas are very, very powerful in that way. And I don't think super controversial.
One of the things that I think could be controversial is, I'm going to put on a CTO hat for a minute, and I'm thinking about reliability. How would you even sleep at night knowing that there wasn't a server you could go hug and flip the switch on?
But wait, did I misunderstood earlier conversation that basically it could be on your own hardware, right?
Mm-hmm.
Is that what we're talking about, right? And then it's not conceptually much different than, let's say, Kubernetes, just because we mentioned it before, kind of you cannot switch off the application because you don't even know where it's running. I mean, it's not peer-to-peer, but it's somewhere.
It's because both systems are distributed, right? So a Kubernetes system is also distributed, a peer-to-peer system is also distributed, and then peer-to-peer adds a ton of stuff extra, like security and this kind of peer-to-peerness of it. But both systems are distributed, and the Kubernetes is a very, very good distributed system also, first of all, like by design. But it's like, and I haven't used this in a while, but I don't know if I would download a container from my worst enemy and trust that worked. I don't know what kind of, checks it does. Maybe it actually does like checks like that, and that's fine. But it's kind of like, it's a different kind of mindset with these kind of like trusted systems in a way. Maybe it does all that stuff together. But like peer-to-peer, again, is about doing this on an infrastructural level where you don't have to think about it on the level above. So like any application built on top gets this nicety. To answer your question about like sleeping at night, I actually have the opposite. Having worked with peer-to-peer in a while now, and like obviously, it's novel technology, and with any like novel technology, there's like an iteration phase with like, a box and stuff that we've been working out. But outside that, peer-to-peer means that as long as somebody in the network, if you build your app that way, has a copy of the data you're trying to do, the system can kind of survive and like rebootstrap and rebootstrap and rebootstrap. The more peers are added to the system, the better it tends to scale. Now, you probably want to run a couple of nodes yourself if you're doing something to like keep that initial spark alive in case everybody's offline for some reason. Like this, the bootstrapping problem is definitely real. For our app, we make a chat app called Keat. It's like chat app where people in the chat, everybody has these copies and they share them encrypted and stuff like that. I run a couple of nodes myself to help encrypted seed some of that data. And I have many times where all that went off because I don't know what I'm doing infrastructure-wise. And the whole network just keeps going. So it actually helps me sleep a lot at night because it's like that kind of infrastructure all of a sudden doesn't matter in terms of like uptime anymore. Obviously, you can run things to make the network better and subsidize the network, but you don't have to think about it so much in terms of like a binary level because it's trustless.
In case peer-to-peer, which I assume that the last examples were more focused on consumer hardware, right? Mm-hmm. In case peer-to-peer is based on consumer hardware, there is obvious limitation. You still need to have more capacity than collective capacity than demand, right? Now, if you go back to 2000 that Darin mentioned before, right? I understand perfectly why I was sharing movies with others. And the reason was because I was downloading movies from others. It was kind of mutual benefit, right? What is the motivation today? Kind of like, why would I right now share my compute with you?
That's a really good question. And I think like having like a general compute sharing thing, if that was the premise of peer-to-peer, where I would tell you, hey, run this program, you don't know what it's going to do, and it's going to sit there crunching 50% CPU, and your bandwidth is going to go high, and you don't really know what it's doing. I think that's a very interesting discussion where some people would be willing to do it, but a lot of people would be like, why would I ever do that? For me, that's actually not what peer-to-peer is about. I think it's actually very similar. I think you almost answered it yourself with like, when people ran BitTorrent in the early 2000s, I don't think the normal people ever thought about it as like something that would be helping resharing to other things. They were just like, I want to get this content, and I use this app to get this content, and I don't really know what it's doing, but it's not doing it so much on the like outside me getting the content that I care. And that's the sweet spot, because the thing you bring into the network resources wise is much, much higher than what the network needs. Like our computers, in terms of like compute, we need to run apps for normal apps, like a chat app. It's much, much higher than per device than what the network needs when you add a new device, if that makes sense. So you can easily add these apps where the peer-to-peerness is just something that the app uses to, like we said before, reduce cost and create reliability, but where the user doesn't really need to care, and also doesn't necessarily need to know in terms of like a UX point of view. Like the user just wants to send messages or like download content. Now, it gives you like an interesting aspect, I think, just thinking about real world stuff that we hit. Like, so in our chat app, for example, like any other chat app, you can share content. And when you share content in the app, like, in the chat, we don't have a limit on that content because we don't host it anywhere. And it's just between the peers in that chat context, but they tend to have a aligned incentive. Like if I'm talking to my wife in a chat, I have a aligned incentive with my wife and stuff. So chat is a really good use case, I think, to both like share those files and make them available for the people in there. Obviously, as those incentives get bigger, if this was like a public thing, maybe it's different. But like, again, you can kind of like build it like you want. The infrastructure doesn't really care in that way. Really good point. I think it's kind of like per app, it becomes less of an issue, like with BitTorrent, but obviously something to think about. We also like, I think also this is a really important point, like something like peer-to-peer doesn't need like a token or anything like that, because you don't really have those like incentive hooks you need to do, like if you run like a blockchain. So it can just be like actual open, free infrastructure.
Is there a major service kind of a normal person, like my mom knows, that is using peer-to-peer? Like Because what you're describing sounds like that my follow-up question should be, why isn't Netflix but peer-to-peer?
It's a really good question. I mean, it's actually hard to know, obviously, right? Because like, also, how do you define peer-to-peer? On like, is it like all on the end user, or are they doing it behind the scenes? A lot of apps also done things and then changed things and stuff like that. I know Spotify used to do a lot of peer-to-peer with distribution in their bootstrapping days. I know from my youth playing World of Warcraft, the installer would like peer-to-peer also those things to reduce a ton of stuff. So apps change and do it differently, right? And apps do it differently based on their model. Some apps try to not do peer-to-peer explicitly. I actually don't think Netflix necessarily would want to do it, because they probably want to have very, very tight control of their user base. They're in the business of slightly biased, squeezing money out of us to watch content, right?
Yeah, but isn't that the reason to do peer-to-peer? My users have Netflix application. And I'm inventing use cases, just to be clear. They have Netflix application. That application is doing whatever it's doing, right? They use it to watch movies, and it is lowering our costs of infrastructure, because without even users knowing, they're actually streaming to other users.
And I think they are doing that. Like, again, like, I'm not inside the data center, but they probably have a bajillion endpoints, edge nodes around the world where they do it like this kind of like in data center distribution between each other, but they're not getting it to the end user, because if they get it to the end user, they would probably be very afraid of losing their control over the content, which I think would hurt their business model, because their business model, again, is about controlling access to content. Like Netflix, for me, is one of my pain points a lot about not so much the technical discussion of peer-to-peer, but just more like also the philosophical one. Like, I'm, again, from a small country. I move between small countries. Netflix controls what I can see in every country because of some arbitrary rules that I don't have access to. My sovereignty on my data is basically zero there. So I think there would be like, we want to keep it very, very tight for that, and then eat that cost themselves because they try to make it back elsewhere.
Isn't it the other way around? In the specific case of your example of Netflix, that actually Netflix would be very happy to serve you the whole catalog. It's just that the country you're in right now prevents it from doing that, because they don't have us legal rights to do it.
I think both, yes and no. Obviously, there's like a lot of legalese in this, but like they do a lot of things, I'm sure, where they base the experience based on what they think I want versus what I can do, because I don't have access to the data and stuff. Like, again, obviously there's a lot of legal complexity in this stuff, and I think that's to some degree a little bit uninteresting in that. Obviously, it's a good use case, and I think they should do it. But like, for me, it's more about making that technology and allow other people to make like a Netflix competitor that technically can compete with a big network like that. Like, Netflix has raised $1 billion, right? So they're like one of the most funded startups in the world. I'm sure they make a ton of money now. I can't remember last what I saw. But like, what peer-to-peer is more about is saying, I don't really appreciate that Netflix model of doing this, but me as an individual can compete with that because I don't have $1 billion. But if I make an app where all that cost can be distributed among users, I can compete with that. Also in a legal aspect. There's no reason why we need to burn all the kind of money on infrastructure. Like you said, it's a very good use case. It still be like a legal app, obviously. And then compete with them and do like different kind of targets on that. And that's, for me, like the long term of peer-to-peer, where once we get that ball rolling, it's like very hard to stop.
What does deployment mean when there's no server to deploy to?
That's a very good question. It doesn't mean a lot. Deployment in our networks, because like, so our chat app is distributed peer-to-peer also. And instead of deploying it, we sign the data, right? So it's kind of like I said, like data authenticity is key in a peer-to-peer network. Like, where does it come from? Can we cryptographically verify that this came from somebody? Similar to how when you connect to somebody over HTTPS, you verify that that endpoint is correct. But don't verify the data, but you verify the endpoint. And peer-to-peer, you do that with the data. So for us, making a new update is literally producing a cryptographic signature for that content and distributing that to a couple of peers, who will then distribute it to a couple of peers, and kind of like spreads out from there. And it's the same flow in our app when you make like a chat message. The app signs that message, boom, done, et cetera, et cetera. So like, there is really no deployment, but obviously there is in that way. Like, that's like, and we have a similar kind of like process around that internally, as you probably do with like a deployment. First, we would test it and have other people test it, and then instead of just deploying it to a server, we sign it and have it spread out. I actually do it all from my laptop, that last part, just my laptop I'm doing this call on now, which is, I think, really cool point. All you need is your laptop to distribute our app to like thousands of users. And I've done that from like my bedroom or my office. Like, I have that signature, it's been tested, it's multi-signed. I paste it into like our little command line tool that puts it into the data structure. it spreads out from my little computer to somebody else and and it's always cool to see.
Isn't that conceptually very dangerous? Let's say that China just kind of Tencent installs an application on your phone, is doing some kind of peer-to-peer, and they promise that they're good guys.
Yeah.
How do we distinguish good from bad? Because I guess that it can easily be abused, right? Theoretically.
I don't think there's any abuse here that's different than a normal app. Like, if you want to distribute data in a normal app, first of all, like a client can choose not to update to the new version, like in any peer-to-peer system, right? Because peer-to-peer also means that they have the data already, so they can just be like, I don't want to do it. That's up to the end client to decide. Obviously, there's an app developer that builds some rules around it. If I have a Chinese app or American app or European app on my phone, and that developer of that app decides to do something that I don't like, I don't think there's any difference in a peer-to-peer system than this. I think that somebody said that earlier, and this is probably similar to, I can't remember, it was the Kubernetes thing, kind of like, once you have an update out there, you try to stop it. It can be hard, right? Because it's kind of like some people would always be like, I have it. That's, for me, like, always interesting to think about. And also, like, in terms of, like, these, like, sci-fi movies with unstoppable AI technology in the future, pairing these things is potentially slightly dangerous, I think. But at the end of the day, right now, that's, like, more of a developer human concern.
My mind is being bent right now. I'm trying to understand.
Right now or permanently?
Okay. Maybe permanently. I'm trying to get my head around. Okay, so I get the signing thing, and that you basically inject it in, and off it goes. Great. But how do I get to that point? It seems like the development process of, hey, I'm going to add this new feature for the chat app, just because that's what we're talking about. How would I think about as a, I'm going to quote unquote, normal developer. I know that I'm creating something that's going to be running with multiple replicas, and, there's things that I can think about that way. That seems to be a good parallel to peer-to-peer until it's not. So where is the until it's not falling in? Because I can't figure out where that barrier is.
No, I think you strike a very interesting point, and I think it's also pretty close, like, honestly, to, obviously it took a lot of tooling to get here, and there's a lot of tooling involved in this, like, with like, we have a runtime, the pair runtime that tries to help you do these things. I'm not, when I say sign and signature, I don't mean like that we get it and then I paste it in somewhere and stuff like that. It's kind of like, you need a bunch of flows. But basically, you just make an app like you do with anything else. For us in the chat app, just to stay on that one, it means that you have an app. It's written with JavaScript and a bunch of modules. We do like an embedded web UI and stuff like that. But you can do whatever you want. We just make an app, and it's like something that's just runnable locally. Now, the big difference in a peer-to-peer app, actually, I think the first big conceptual difference is that, how in a normal app, when you make something and you start to get a little bit serious, you'll always have that config file where you put in like your database config, right? Your JSON file with like, here's my database and my token, and maybe I'm running it locally, or maybe I'm running it on hosted something, and you have different environments. Immediately, you'll notice a difference in a peer-to-peer system is that you don't really have these environments. You can if you want to, but you don't need to, because everything is just local software. So like a database in a peer-to-peer system is just system software that runs embedded in your app. And obviously you can talk to other people if you want to, but like when you're doing development flows, you're just making a local app. Everything is local. If you wanted to talk to other people, you would have some flow where you add them in our chat app. It means send them a link to join to a room, and then there's some peer-to-peer magic there. But you just make a normal app, you run it, you test it. You have a normal software flow, you do normal sprints, you have normal QA, people testing it. It can be a bit harder to test, honestly, because conceptually we've all been educated in centralized systems. Here you have to more test, like, I always get this question, like, how can we offline test? And I'm always like, what does offline mean to you? Like, offline from what? In a peer-to-peer system, every peer is online with themselves. Like, what does that mean in like a classic binary offline-online context? It doesn't mean much. It's just like, obviously, it's better if you're connected with other people. But maybe us three are on a plane and we want to talk to each other. That's still a valid use case. So testing can be a little bit tricky there, honestly. It's something we're working on making more tooling for. But then you just make the app, and when you're happy with it, you just run another command that just takes that app, diffs it with the previous version of the app, makes an update, puts it into this peer-to-peer container, kind of like a Kubernetes container to some degree. and sends that off to like whoever wants it, whoever connects to you based on this protocol. So everything is really simple and straightforward until you get to that last point. I actually would dare to say, slightly biased again, that it's easier than normal development because you don't have those intense external dependencies that you need to worry about, like connecting to databases and stuff. Slightly biased.
It's because the data is local, always local.
Always local and distributed, or like, you're querying it from somebody else who's just a peer, but like running the same software.
Oh, so it doesn't have to be local. It could be a query off to somebody else that has the data that I don't actually sync in.
Yeah, so then in a peer-to-peer system, what that means is that, kind of like you and I are chatting, right? So in a peer-to-peer system, when I write a message, I just append that to my local database. Then when you write a message, my local database says there's an update, and then I can query it. But querying it just means replicate your peer-to-peer data to my local instance and then read it locally. So it's kind of like you're always reading it in and reading it locally. Just to continue on that, like maybe we have situations where you have thousands of chat messages. So the peer-to-peer network, tech-wise, has to also offer, again, within this framework of like everything can be verified yourself, abilities to just get the last message and stuff, or like some query or some index as we used to with databases. We've done a ton of work on that, and we have a ton of R&D and software available for that. But that's like actually a very hard problem if you started from scratch.
I'm going to go back to the CTO hat again. How do I back it up, all this data? Do you not? It seems like there would have to be at least one node, preferably at least two, that has everything. I mean, everything.
It's an interesting question, right? Because like, what does a backup mean in a peer-to-peer network? Kind of like if I was being slightly trollish, I guess is the wrong word. I don't know what the positive word for that is. But like, what does a backup mean in a peer-to-peer system? Because like in a chat, like in our chat app key, there is no global backup because there is no global system. Like a chat backup can be maybe yours and I chat is very important to me. But we also both have a local copy, right? So like there is two local copies available. I can also link another device at home. Then I have another copy because it's all just peer-to-peer data that's running on the same protocol. We have some tooling for running, kind of like we talked about in the beginning, a general instance that just only deals with syncing peer-to-peer data, not really running the applications. Now, I'm okay running that myself or using somebody else's if they're okay with it, because it's like this data is very valuable to me. So there's tons of tooling, but conceptually, I totally can understand why also that can be honestly hard to wrap your head around. It's still hard for me to wrap my head around sometimes. Because there's not one global system, you don't need to think about backups in this global way, but you want to have a bunch of small ones. In Keto chat app, the most important thing we back up is like what we call your own profile, which is basically just like, who am I? What's my name? What's my avatar? What's my list of the chat rooms I'm in from myself? I only share that ever with myself, but every device I have a copy of that, so they can also always bootstrap from others. And then we have options where, again, you can offload that to some other peer if they're willing, because that's all at the end of the day end-to-end encrypted. So you don't really leak much in that sense.
Backup feels like a wrong ask from Darin. The better one would be, how do we ensure the data is not lost?
Yeah, it's like a mirror, right? That's kind of like, or like a replica exactly. Is what we call it. And you just do that by adding more peers to the system and have those peers be willing to host your data if they want to. I think the hard thing in the peer-to-peer system with this also is kind of like there's levels of this. Right? In the chat app, I think that's, again, because the chat app is just fun because it actually ends up doing everything in the world. In a chat app like ours, I can go into a DM right now and I can add a terabyte of data to somebody if I wanted to, because it's just between me and them. Do I care about me bagging that terabyte of data up? Maybe not. Then I can choose to like unlink that one from the peer-to-peer network and like not have that sync between my devices, because that would probably cripple some devices, right? Maybe I wouldn't want to run that on my smartwatch. And the technology allows you to do that.
It feels that the question is wrong. Do you care or no? You're, as a user, you use an application, you use a system, you expect that the data is there. And if I follow your example with 1 terabyte data, how do you ensure that 1 terabyte is not lost the moment I close my computer, right? Is there some kind of guarantee? Okay, so we guarantee that this will be propagated. And I'm probably speaking in terms that are inadequate for peer-to-peer. So correct me at any moment. But kind of, do we somehow ensure that terabyte data is at least 3 devices or something like that?
So first of all, it's a very interesting problem also in general, because if you think about it, and especially in a peer-to-peer network, it's very opposite, because again, every peer has the ability to help you create a copy of that. Let's just make it simpler and not say the terabyte file, but just say the chat, just because it's easier conceptually to think about. So if you and I have a chat, I'm a peer and you're a peer, and we don't have any other devices, just one device. It's actually the weakest peer-to-peer network if you think about it, because it's a peer-to-peer network where if one of us goes offline, 50% of the capacity of the network is lost. Like, it's a very, very high churn network, percentage-wise. Now, why is that interesting? It's interesting because then we add somebody else, and all of a sudden that percentage goes down, and we add somebody else and that percentage goes down. So like the more people we add, the more resilient the network becomes, and the more on the peer-to-peer side scalable becomes, because there's more available capacity in the network. Not necessarily for hosting everything, but like ensuring at least that the data can be spread around. In a centralized network, it tends to be the opposite, right? Like the more people you add to it, the more it tends to struggle, and the more you need to scale something else, because like there's a difference between consumers and producers.
Yeah, but you're scaling something you control, right? In peer-to-peer, you don't control it. Kind of like, I don't know, 50% of my users just stopped using that application. Kind of, I lost 50% of the network, right?
Yeah.
How does it ensure that actually all the data that ever existed is in the other 50% in a way, right? If it doesn't know which 50% is gonna choose to leave in a way, right?
So my point is, like, the small networks are very hard, the big networks are very easy. It's a nice problem to have because the small is simpler. The way you solve that is you just add more peers to the small ones, so you can have other peers help you with the small ones to reduce that. You could also, like as an app developer, subsidize that if you wanted to, the very small cases where have other peers help hold the data for a little bit. That's what we do in Keat. We have, again, this like generic, because it's all just generic encrypted peer-to-peer data, so nobody cares. And that's how you solve that from a user's point of view. Again, all the data is on the devices. Every data you ever seen is on your device, so you can always sync between devices if you wanted to. I think that's a very nice guarantee. You can also, again, if you wanted to, if it was very important to you, you can always add another peer that just mirrors everything like you do in a normal centralized app. You don't have to exclude that option. Nobody says that's like an option you're not allowed to do. Just that the peer-to-peer system gives you more possibilities. So you know how like Facebook and all these apps are always like very aggressive about, I think it's compliance actually now, but like they always want to give you this like data export option. Like let's have a data export option, which is kind of like you could get some static copy or whatever. Because in a peer-to-peer network, that's just always can be aligned to like, well, what's your public key? That's here you can get the data, and you can have it be like live and live syncing.
I was thinking more from the perspective of the Facebook users which is probably 99%, who never actually realize that there is an export option. Mm-hmm. And the system should work for them. Like when you tell me, hey, you can add another device to that for the sake of your data being more secure, what's or not, kind of like, that's not a user, right? That's a very specific power user. You know, that's what my daughter would call, that's a nerd.
I'm not talking about power users. I think for normal users, this kind of requirement is fine because they don't have to use anything. Because again, the Facebook chat would scale with this normally. Again, the app would add more peers to kind of like subsidize these small things. That's what Keat does. In Keat, the app, there's never a point in that app other than in the initial page where we say it's peer-to-peer because we're proud of it. But like the app will just be like, it's about chatting. The app is about chatting, and the rest is just like something that happens, and you tend not to lose anything because there's always capacity somewhere. But it's like, to concede to your point, there's like obviously more probabilistic things in a network like that. I'll be happy to say that. The upside is that everything is free forever.
Free forever. Really?
It doesn't cost us anything to run it, right? Like, because peers don't do it. The only thing I always say, we're in the business of
It does. You eat food. I'm sure.
Oh, sorry, that was my next point. I was just going to say, we're always in the business of...
There is always a cost.
We're always in the business of like, if we go bankrupt, the apps will still work, right? So it's kind of like, if I've stopped working tomorrow, the apps need to still work. Obviously, like there's development costs and stuff like that. I'd be the first person to concede that. But like that's cost where I put it into my like budget spreadsheet, and I can be like, what's my development cost today? What's my development cost tomorrow? How many users do I have today? How many users do I have tomorrow? That's a flat line. Like in any kind of other app, it's like, well, depends if we get like overnight growth like this, we got to start worrying about that budget, and maybe we should start raising some money. I have like, I do budgets like probably we did in the 90s. I have like a 5-year budget that's like, I know what I'm paying today, and I know what I'm paying tomorrow. And I think that's like combined with this other stuff, like potentially a big game changer for this, because it also allows you as an app developer to just focus around features. Like we never do a feature in our chat app that's like based around costs. There's some features where like, kill me now, that's really hard in terms of like peer-to-peerness. which is like very fun sometimes. But like in terms of like features, it's actually really relatively straightforward. Is this good for the user or not?
This seems like the ultimate, it runs on my machine. What happens when it doesn't run on my machine? I mean, as a developer, I'm sitting there, I'm doing it. It's like, okay, great. It runs on my machine. And then everything gets seeded. I go and install it on my machine. And now it's me as a different person. And then it doesn't work. How do we debug that?
So now this is a great question. Because like I think actually you touched now on, I said a lot of very good things. I think that's actually one of the hard things in peer-to-peer, like debugging in terms of these things. And there's something we're also still figuring out. I had the pleasure of talking to one of the co-founders of Skype a couple of weeks ago, and I asked him this exact question because Skype was very big on being peer-to-peer. And I was like, how do you debug these things when it's running everywhere? People have different versions and stuff. He was like, you just go with the flow. And I was like, oh, that's kind of like this. That is a very, very good question. And I think like I don't have like the ultimate answer for that yet. What we're doing right now is we're trying to make that as seamless job as possible. And that's why, for example, we did this thing recently with our JavaScript runtime Bear, which is kind of like this foundational piece that runs on every device that kind of like abstracts the interaction with the system. Not so much, just kind of like this, like a JavaScript runtime. So, because we're JavaScript developers, but just so you have a consistent interface, we can test on all devices. It's very simple. It does very little. It's very modular. So when we write code, kind of like the promise of Java back in the day, we write code for desktop. It runs on the phone. It runs on the smartwatch. It runs on anywhere else because it's just running against this like single JavaScript runtime layer. And that definitely makes it a lot easier. Deploying stuff in the PHP layer is always hard. But honestly, I would then say it's probably not that different than deploying today in our world, like in that world of apps, phone apps, just tons of software to tons of different phone apps because it's kind of like the same. Obviously, the apps do more in a peer-to-peer network, 100%. But you still have the same challenges of like somebody's on a freaking 14-inch screen and somebody's on a 12-inch screen and somebody's holding a this and somebody's holding it upside down. And support can be hard. Like in a peer-to-peer network, we get the support requests sometimes where they'll be like, it didn't work. And we'll be like, oh, I don't know. And then they'll come back and be like, oh, it turns out I didn't have any connectivity. So they didn't get my message. I'm like, okay, well, sure, then it won't work. And things like that, right? So it's kind of like, because, and then peer-to-peer is also very self-healing, which means that if something goes wrong, it tends to then correct itself because it's self-verifiable and stuff. So there's definitely a lot of challenges that we are consistently working on in our company of making better, a lot of tooling. Peer-to-peer also right now, and that's for our chat app, we feel this definitely focused a lot around like privacy and sovereignty, like holding your own data, don't talk to anybody, being private, being your own citizen in this digital world, which also means that collecting logs and collecting stats from these apps is basically like a very big no-go for most users and also for myself in that sense, because you don't want to have that centralized entry. So that can also be a challenge. And so you need to rely more on classic support and stuff.
Going back to the logging, couldn't you still log locally?
Yeah.
In the app?
Yeah.
Outside of, because to me, it's still, I've got a desktop app. I've got a mobile app that's then connecting up to a data store that is peer-to-peer, right? That's the effective architecture. It seems like, yeah, I mean, but then you still don't want to pass, even if you collect a bundle, a support bundle, for lack of a better term, you necessarily wouldn't want to submit it, but you could, right? I mean, you as the author would love to be able to get a whole bundle of, okay, this is the state, because we're seeing this weird thing with, Debian 10 to Debian 12 to Debian 14. It's like, okay, what happened?
That's exactly what we're doing. So we have a bunch of local logging, and we also log like non-sensitive stuff to like a P2P data structure that is fully locked down to the device that a user can then give us access to if they want, which we only use for mainly internal testing and stuff like that. But like, so you can do it for just logging like very strange events, like you said there. So you have a bunch of options. We have a bunch of open source software for that. I won't deny that that's definitely like a challenge that's more unique to peer-to-peer, because you don't have just like an explosion of different devices. That's definitely true. So it's something you need to think about from day one, I think, also. And not but like you said, in any real world system, you need to do it anyway.
You just said something there. You sort of glossed over it. A separate private peer-to-peer structure. So that's something I hadn't considered, is you can have multiple peer-to-peer data structures running underneath the app at the same time. Yeah,
and like our chat app, for example, because it just uses this one primitive we made, our open source core foundational building piece called the hypercore, which is just a very simple peer-to-peer data structure. That's like the unit of operation in the peer-to-peer world. Is like, this is one stream of data that you can random access and stuff like that. And I think for like one of our bigger active chat rooms we have, there's like around 6,000 people in that one, like our community room. The amount of peer-to-peer data structures that has around 40,000, something like that. So like a lot of very small modular pieces that each can be shared on an individual level if you want to, because these are very, very small and very efficient. So you have a lot of possibilities. It's very, very modular. It's very, very, not like configuration heavy. It's very low configuration, but it's more like composing. You know, it's kind of like, I'm from Denmark, so I like to say Legos, because Legos are from Denmark. You build your little thing up, which can also, I think, be a little bit overwhelming for somebody starting, just to be transparent, because you have all these different options that is like, but you can basically compose things very, very differently. So if you think about it in terms of like a chat app, I think that's interesting. Like, so the chat app itself is in the P2P network. So that's obviously a very, very public data structure that is available for everybody. And I actually don't even think we encrypt that one, because we're like, why at rest, obviously in traffic, but at rest, because why would we need to? It's like a public thing that just spreads around. But then you have the chats, which is obviously very, very sensitive from the user's point of view. So they are like mega encrypted at rest also. So if somebody ever got access, like this defense and dev thinking, somebody ever got access from the device is still encrypted. If you ever mirror it for somebody else, it's still encrypted. But it's the same peer-to-peer building blocks. So like the stack doesn't care about any of this. It's just one peer-to-peer stack. Kind of like how TCP/IP in the normal internet doesn't really care what you're doing on top. It just has one job, which is delivering that stream of data. And that definitely makes our life easier.
If somebody wanted to get started, you sort of lean into this. If somebody wanted to get started developing a peer-to-peer app, what would be the first thing? What is the hello world of peer-to-peer?
That's a great question. I think the hello world of peer-to-peer that I like to do is actually just having, because this is the demo that got me introduced into peer-to-peer originally. You just have two devices. You install our software on both. One of them, you make a little node that has a server, we call it, but it's actually just like a public key that you can connect to. And then the other one, you connect to it. And then no matter what final firewall stuff they're on, they will find a way to penetrate those networks and connect and do like a secure stream. And then just send hello world. I love that one because it's like 5 lines of code on each device. And it really tells you the power of like utilizing your end user devices as any kind of device. We've done a big push on trying to make this consumable for users. We have a ton of stuff. I work with Italians, and they like to, when I first started, they always mispronounced peers as pairs, as the same word, like peer and pair. So we use the pair as our go-to emoji. We have the domain, there's the one domain we have, pairs.com, where we try to document all of this. And like, if you go to there, there's like ways to get started, all open source. And also links to we have a bunch of active rooms on our chat app, Keat, where we are, as developers and stakeholders, very active in trying to help people build, because we love people who build. Again, it's all free. There's no token. There's no catch. We're just building out this infrastructure for everybody and for ourselves. It's definitely really, really fun to try out. Maybe you have a lot of feedback. We want to hear that, but it's like, it can be very consuming, as you can tell from me.
If it just wasn't JavaScript, it would be so much nicer. But that's fine.
So we have a native layer that we're working on also, and like our JS engine is exposing everything as this native building blocks, and obviously we do all our encryption in C++. That's the only real way, and we do all our networking in C++. So we have a ton of stuff. We're always exposing that stuff. JavaScript for us is a good language because it's very, very good at moving data around. It's a good at discomposing layer, and it runs everywhere. Can be very, very fast when done correctly. But I hear you. I'm all for like more support. What's your language of choice?
Me is Java. Victor is Go. And we have other people listening that it's going to be languages all over the place.
I grew up on Java. That was like very big when I hit school. I'm a big fan. And Go for me was always like somehow like a spiritual continuation of Java. I think in some degree it's kind of like, that's how I see it. Like
more like a spiritual continuation of C.
Yeah, I was gonna say like a hybrid of C.
It's
C
the
and Java.
only language
It's kind of like that.
I know that is as simple as C. Right? All other languages are kind of overloads. Right? Go is C simplicity. You can explain Go in the same number of pages as what was the book, Richie something.
Yeah. I'm a big fan of JavaScript because JavaScript is kind of ugly. So it kind of like it's a language about getting stuff done for me, and not so much about making like programming art. but I'm a big fan of like programming languages.
Now
in
I
general.
understand why you're so interested in peer-to-peer. Since you need to download whole internet through libraries for your application, you need extra storage. That must be it.
But JavaScript like is also very, very good at interfacing with like native stuff, as I'm sure all the other stuff is.
True.
But so it's like it's a good choice. But like again, this stuff is agnostic. It's just protocols. I think, or we're definitely looking into a future where there's going to be very strong bindings for all kinds of languages, and I'll keep you guys' choices in mind. It's good choices.
All of Matthias's information will be down in the episode description. And again, it's at pears.com. Pear, like the fruit pear, like apple pear, pears.com. And if you're curious about the company Bear, it's bear.pears.com because you probably couldn't get bear.com.
No.
I don't know that you would want to have gotten bear.com.
And Bear is our JS engine, and our company is actually called Hole Punch, but it's fine. It's too many words. But like, go to pears.com. We have links for everything there.
Matthias, thanks for coming on today.
Thanks for having me.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.